we're going to go back. This is the September 22nd here slides. So we're going to go back and we're going to talk about the code here, because this is where kind of visualization begins. Now, last week's big topic was visualization, and so I'd like to just go back and talk about how visualization helps to understand large amounts of data. So if you go to the code that in fact, you'll find the fresh code now in your class docs repository for the 4th week in Sandbox, you'll find the coronavirus analysis directory, and in that you'll find the some code. So specifically, if you just go and if you navigate into that and find a .r file, and you right-click on that, and you open that with your RStudio, then you should be able to get in, and you should see this. Is everyone able to do that? If you're not able to, if you have some trouble, please just unmic and or unmute rather, and let me know. Otherwise, I can't always see my chat, which is just because I have so many things open on my screen here. But just let me know, and I'd be glad to stop, and we can talk about why it may not be working. But I'm going to assume now that you can get into RStudio, you can get into your class docs, and you can run RStudio. And one thing I would say, though, and I know that you can't really see this, but in my RStudio, if I go to, where is this now? If I go to the RStudio menu option, and I find my preferences, I don't think you can see this. You can. Yes, you can see that. So this is my preferences for RStudio. One thing that I do is, you can't see this, but under Workspace, in the middle of this panel here, there is a restore.rdata, and then there's an option underneath that says save workspace to rdata on exit. It's right here, and you can't really see this, but I always have this set to never. I think on your machines it should also be never. But what I'm trying to do, though, is I'm trying to prevent RStudio from saving my history. And I know you might be thinking, well, why would I want to do that? I want to hold on to my code. But I find that encourages a bad coding with RStudio. In fact, what you want to do is you want to take all the code that works and put that into a file. And we'll talk about that as we go through this, but you want to take all the code that works. Like every time you define some variable, everything that you do that makes something happen that you want to happen, you want to put that into a piece of source code and then to save it so that you have it. Now, if you rely on using the workspace, like in other words, the history of all the commands you've ever typed in to get back your code, then think back to all the stuff that you type in that doesn't work. And so that's just going to confuse you. And so it'll be 3 in the morning, it's like Monday night, you have to get ready for your Tuesday class, or you're trying to get some code ready together, something, or you're getting ready for your lab, and you're trying to scramble through this. And you're thinking, what was that command? So then you go through your history and you have to try every single thing. But when you try your history, when you go back through your history and try that old code, and this is a personal thing here, but I find that just makes things worse and makes me actually kind of confused. I don't seem to, I'm unable to actually get things to work the way that they should work. Let me just do something here. There we go. Right, so I always have this on, so I save workspace on RData. I say never, because I don't want to, I want to take all the code that I know works. Yes, sir. Alex?
Access that menu.
The menu. So in RStudio, so you can't see, I wish you could see this. But you go to the RStudio menu itself, where there's this About Studio, and you go down and there's a Preferences. I wish that you could see this. But I wonder how I can remove. Sorry, let me just see if I can get rid of this. Maybe that's better. Okay, so I'm hoping that if you have any trouble finding the Preferences menu option in RStudio, please let me know. But it looks like this. So you have like all the options that you can play with, and you just go to the General, and there's this thing that says Save Workspace to our data on exit. I say never, and that's just so that I don't assume that all my code that I'm writing is going to be backed up someplace where actually I can't really get to it anyway, though, because it'll just be a mess. Because I tend to type in a lot of stuff that doesn't work, and then some of the things that I type in are just pieces of bad code that maybe they actually create variables that I really don't want floating around in my variable pool here, and so that just makes things worse. And so that's what I use. I mean, you can compute the way you want. I'm not going to tell you how to compute here, but I'm thinking that this would be helpful to you too, because it will encourage good coding practice. Right, so I'm going back to this code here. I'm actually looking at the compare countries underscore 22 September 2020 R. This is going to be a file that you'll find in your class docs repository, and so it should all be there. This is slightly modified code here from what we saw before, but I just wanted to take you through this code here because I know we were kind of rushed the other day, and I think that actually this is actually a kind of an interesting piece of software to look at. This first line that we have here, rm, and then there's parentheses, list equals list, or list equals ls parentheses. That is our code to remove all variables that you have floating around in your memory. You want to get rid of those each time you run a new piece of software. Each time you write a new program, get rid of the old variables. Why would I want that? Because I want to know that if I were to give this code to one of my colleagues in this class, for instance, like I've given you today, I want to know that I didn't type in a piece of code down here someplace, and in the editor part, like at the bottom here. I want to know that I didn't type in code down there and then create a variable in my environment, which then my code up here is going to be using. So in other words, I want to make sure that all the analysis, all the code that I'm writing in R is actually happening from this code here. Otherwise, it's very simple to come down here and then to assign a value of x is equal to, say, 10, as you can see in the bottom. And when I create that variable, maybe that makes this code up here work. But then again, when I have closed out my RStudio, when it's closed, that means I lose this value of x equals 10. And when that value is gone, then later on, when I'm running this again at like 3 in the morning on some night here, some school night, I'll be shocked to see that it doesn't work. And so what I want to do is I want to have this piece of code in here to encourage me to always, always, always assign my variables as I need them. Otherwise, I will have all kinds of trouble when it comes down to creating working code in my project here. So I'm going to remove this. I don't want to assign any values down here. If I do assign a value down here, if I do assign any values down there, then I want to make sure that I put my values in the code here. Put your code here, You can always use comments here. That means if I have this hashtag in front of my code, like I have right here, that means that everything is basically ignored. One thing I will tell you, though, that's interesting in our studio that I really like, is that if I have a piece of what appears to be code, if I'm writing a line of code here, but it's not actually syntactically correct, it's not our code, it's just maybe junk or line noise or something, or if it's an error, you'll see that on line 6, just to the left, there's a little X in a red bubble, right? What that means is that R has gone through and checked my syntax and said there's something wrong. The line won't work as it is. And so that will help you to be a better coder when you are going through RStudio, because you can see whether there's any errors on the line, and if you're trying to debug something, if your program continually crashes, then just look on the left-hand side of the line numbers and see whether anything stands out as being erroneous, anything doesn't work. Anyway, I think I've said enough about that. Now I'm going to go and click on remember as you run R though, you basically put the cursor on the line where you are, and then you push the run button, which is at the top here. Or on my Mac here, I can push the command button, which is on the right-hand side, and I can push return, and it will run that line. But it only runs one line at a time. And the reason for that is because sometimes you don't want to dump out the whole code. You don't want to run the whole code at once because you may have different plots being prepared by different pieces of code, and so you don't want to go through and run everything, because then all those plots will come flying out, and you won't have time to see any of them, because all the plots that you create in the beginning will be overwritten by the plots that you create at the end. And so you want to run this through line by line. And I find that when you're going from Python or Java to R, that's a kind of a hard lesson to learn, because many people think that when they just push this run button that the whole code runs. And I've had messages coming through, like last semester there was somebody who said that they had spent 3 hours at their computer trying to run a piece of code that would have run in like a second. And I wrote back saying, this is on Slack, wrote back saying, why did it take you 3 hours to run this? And they said they didn't realize that they had to push run for each line. So I don't want anyone here to waste their time in this, on these things here. There's too much fun to have in this course, and I don't want you to be wasted on stuff that just makes us all annoyed. So each line, run. So I'm going to run through here. Now, one thing I will say, though, in this code that you're seeing now, I've added these lines here. In fact, if you want to go ahead and uncomment these things, just as I'm doing here. And I'm going to run them. And when I run them, it will restart my R session here. I have an error here, but that I've already installed my packages. Excuse me. But what it's doing is it's going out online into the cloud, and it's downloading the R packages. That means it's downloading libraries or pieces of code that I need to run my to actually assist in my code that I'm running here. So we use tidyverse, and one of the things that we need to use in this particular program here is a plotting function, and that plotting function comes out of tidyverse. Now, we have another plotting function which comes out of plotly. And so I need to make sure that those libraries have actually been downloaded from the internet, from the repository for R, and then have been installed on my machine. And so this is really just, if you're thinking in terms of like Linux or Windows, you're just installing software. And now each time you've installed this software, or actually if you've installed this software before, you don't need to do it again. So I leave these lines in here. I didn't do them last time, and I do apologize, but I'm going to leave them here now so that if you're running this code on a different machine and you try and load these two lines here, in other words, you're trying to bring into the program these libraries or these parcels of code so that you can use them, if you find that there is an error, then it means, for instance, if the library hasn't been found, then it means that you have to go back and run these lines here because the libraries themselves haven't been found. You can think of this in terms of if you're trying to make something like bread at home. This is your recipe that says make bread, but the recipe itself will say locate flour. And so if you don't have flour, then you have to go out and buy flour. And so you have to basically install flour in your kitchen before you can make bread. And so the libraries are like series or lists of instructions, but the packages themselves are the ingredients to make those instructions happen. So if you think in terms of that way, and I think that'll help you to kind of realize when you need to install a package and when you need to use a library. Now, if I'm speaking to, if you think that I'm kind of undermining your intelligence, if you've been through this before, I do apologize. I'm speaking to the people who have perhaps never seen R before, and this is all a new experience. I know that when I first saw R, I had something of an allergic reaction to it, and so it took me some time to actually generate some kind of, or to actually acquire a taste for it, which is, I think that R isn't an acquired taste, but I think you'll find that it's actually okay. So I'm going to run my libraries again just because they're, whatever. I always have in my code and use it to documentation. So for instance, this is documentation when I'm talking about where some of this code came from. I mean, I wrote parts of it myself, but some of it was inspired from here. But more importantly, though, the data itself comes from this place. Now let me just show you this website for a second here. I'm going to go ahead and copy this. Now I'm going to go to my, where can I find this here? Can I show you here? Yes, I can. I can make a new thing. And when I go ahead and dump this in, this is somebody's GitHub repository. I don't know who Rami Crispin is, but they are curating this coronavirus that we're using here in this program. I think they have some other analysis tools, and you can see what they have going on by just clicking around. But this is like a repository that you and I would use for our homework in lab. So I found this just by going to the data, and then in data you find this file here called coronavirus. And if you click on the coronavirus, I think there's somewhere that says there's a button here. I wish you could see this, but there's a download button to the right of basically where I am. So I'm just to the right of where I am. This download button, you want to click on that button, and then it will download the file, and the file is going to be, you can't see what I'm doing here, but it will download a binary file, which is the data. It's not a text file, it's binary. And the reason why I'm saying you have to use that download button is because if you try and do a save link as, then your browser is going to try and download the file as text, and that's just going to make it, it's going to corrupt it. It's not going to work for R, and so then you'll be trying to run your code and nothing's going to work, and then the whole thing will end in tears. So going back to the R Studio, that's where the data comes from. And that's very, very important that every time you're using a project, or you have a project where you have data, I cannot under express the importance of this. But it's very, very important that you are sure to cite the data, because the data, whatever claims you come up with, anything that you say or anything that you find and that you report from your analysis is a direct result of your data. And so if you find that you're finding something that just seems absolutely incredible, just crazy, just out of this world, that it couldn't possibly be that way, then it could mean that it's not your code, it's not your analysis, but it's your data. And so that means you need to go back to your data and see, well, is my data substantial? Is there something wrong with it? And so if you have this link here, that means that you can go back and check these things, because you will find in data analytics that some data is just wrong. It's just bogus. Someone has created a program that makes random data which isn't actually correct. It's data that fails. So if you cite it, that means you can go back and check it and see what's going on. Now I'm down here to these lines, and I'm going to put my cursor here. I'm going to run this line here of my file, and you can't see where I am here, but I'm going to go through and hunt down the file coronavirus.rda, which is going to be in my class docs repository in the week 4 and sandbox. Click on that, and then you'll see that this is where my file is actually located. If you can see this on the screen here. My face is actually blocking things out. That's too bad. When was the last time I ever got mad at myself because I was standing in the way of myself? Let me see if I can move that around here. Sorry. I have to go back over here, and then I have to go back to my small cam, and then I need to move this thing down. Maybe I can move this in the corner somewhere. Hopefully I can do that there so that you can see what I'm doing, and then maybe that's good enough. Maybe that's better, I don't know. Okay, so there's that. And so now I'm going to be moving that. So that's where my file is actually stored. So I use this file choose piece of code here, and that's where I got the file from. And then once you have the file, notice that all this thing does here, it returns a path and a string of the file name. And the path and the file name, it's all that's all that I get in my file. That's still not the data. The next line here, load my file here, that's where the data actually is incorporated into the machine here. And that's where you see this at the top here. You'll see coronavirus under my global environment on the right-hand side. You'll see that I have 190,755 observations of 7 variables. Now, I'll just show you some other things here. Before I actually print this whole sheet of data to my screen here, I run this simple code here called unique corona $country. Let's just, actually maybe I should show you this first here. Let's just show you the data. This countryside over here, this is a column header. Hang on, let me go back here. This is a column header, and this prevents, that's also a column header. This is my data set. Coronavirus is the data set that's what the data is called, because that's the file name. And so that's what R is calling my data. But coronavirus is the data set. That's how I refer to data. And so I'm saying unique, that means show me what the unique entries are for the column, in this data set, column country. So what does that even look like here? So if I go to my data set itself, hopefully you can see this, you'll see that I have the date in my data set. I have Provence, which basically means, like, if it's not the country itself, maybe it's in this case it's talking about, for instance, you have France, but France also has protectorates like French Guinea and New Guinea and Haiti and some other places. And so you have countries which are associated with other countries. And so the Provence really means that if I'm looking at Haiti, then I need to go after this column here to actually pull that data. What I mean by that, I'll talk about it in a second here. I have the country information here, so I have, like, for instance, Afghanistan. I can scroll through this. You can see kind of I'm moving through. I have the latitude and longitude moving to the right of the country here. That's like the actual map location of where these countries are. And then I have the type. And now remember, this is confirmed cases of coronavirus. And the last way here, the last column that I see, is cases. How many confirmed cases of coronavirus were there? And you have this here's Albania, for instance. I have every single country on Earth in this data set. And I can see those countries by typing in, let me just reduce this a little bit here. If I type in this unique corona country, I know it seems like a lot of stuff here, but I have 188 different countries that show up on my screen here. And so that means that I have data for 188 different countries. So you can go through and you can find seemingly all countries in the world here. And I have to say that when I see how many millions of people out there are suffering because of this virus, it really makes my heart go out to them. And so I think that data like this is especially sensitive to me, though, because I realize, though, that I'm not just looking at numbers anymore, but I'm looking at measurements of suffering, death, and other things. But I'm looking at how many people across the world are suffering because of this virus, which makes it very important that we wear our masks, wash our hands, and take care of ourselves and defeat this thing. Because otherwise, all these cases that we have here, and this is a complete rant here, but all these cases that we see will mean nothing. Here's Afghanistan. I can see, for instance, in 2020, is that May 10th, there were 369 cases. And you can go through your whole list of countries here, and here's the United Kingdom here. Oh, this is interesting here. So this is Gibraltar, which is a protectorate of the United Kingdom, and so you'd have to worry about, if you want to look at the information about Gibraltar, you'd have to look at, you're looking at the United Kingdom, but also under United Kingdom, you're looking at Gibraltar. So what I'm saying is, when you're looking at country data here, you're not just looking at the country, but you're actually looking at the province also. Anyway, I'm digressing. Getting back to the cases here, or getting back to the code here, you can see that I'm actually locating, if I can see the numbers of the unique countries here, I can also see the unique provinces here, or the protectorates of these countries here. And so I can see that there's a bunch of places that I have heard of, and other places that perhaps I haven't heard of. But these are all associated with different countries. And so, for instance, if I'm looking at Macau, for instance, if I want to find out about Macau's infection rate here, I will also have to find out what country is associated with Macau in order to pull out this information. You'll see that in the code. That's the piece that I had to change, which is what you didn't get last Thursday, and that was the bug that I was talking about, that I wasn't making any use out of this province piece of information here when I'm actually looking for country information. Okay, so you have the data, you have the code here. Now let's start doing some plotting here and just getting an idea about what's going on in the world here. So I started out by looking at Sweden. Now, Sweden, I created a new variable, which I call Sweden.dat, which is a subset of the coronavirus. This over here, by the way, this is our code for piping information from one function to another. Every time you see this percent greater than percent, you can think of it in terms of and then. And then. So coronavirus, and then, and we're going to talk about this today, filter. We're going to filter out, that means we're going to actually extract specific pieces of information from our main piece of data here. So I take the main data, and then I pull out some specific piece of information here. And then I have to select that information so that that's being sent into into memory, I guess, so I can actually start plotting this thing here. And that's how we actually create subsets of data. Now, if this code means nothing to you right now, well, don't worry about that, because I think that if you just remember that this is your basic standard way of pulling code out of major chunks of data, then you should be good to go. This is actually how you're going to be working with your, with actually pulling information out of, I think, seemingly most types of data sets here. If you need to, when you get data online, for instance, you don't need everything. In fact, most of the time you'd probably want to throw away most of it. But you want some specifics here, and so this is a way of going after it and saying, okay, I'm creating my own sub-data set here, which is called Sweden.dat, which is a subset of coronavirus, from which I have pulled out specific information where I'm saying the country is equal to Sweden. So in other words, I'm going back to my data here and see how I have this column here called country. In fact, I'll just show you. I'm looking at this data here. You can't really see it here. Here we are. So, and in my data set, I have Sweden. And so I'm saying, okay, I want the number of confirmed cases for Sweden. And you'll notice, though, that I have this province is equal to nothing. Why do I do that? Because in order to get the numbers that concern Sweden here, the country Sweden, you'll see that province has nothing in it. We'll talk about these functions today, in fact, once I get done with this. We're actually going to talk about these functions today. And so it should make a little bit more sense. But this is just put this on your radar for now, that we're going to be using the filter command. So what I'm doing is I'm actually going through the data and I'm pulling out specific pieces of information that I care about. And also I care about, for instance, type. Notice how these are all requirements. I'm saying country must equal Sweden, Provence must equal nothing, and type must equal confirmed. And so going back to my data here, I'm saying, and here's Sweden, Provence is equal to nothing, country is equal to Sweden, and the type, which is second from the last on the last header here, type is equal to confirmed. And so that means that these are actual cases. I'm actually collecting the numbers in cases that concern where those conditions are true. So that's what this piece over here. So I'm saying select. Once I have found all the rows where Sweden, Provence is equal to nothing, and type is equal to confirmed. Once I've pulled all those rows from my data set here, and then what I'm going to do is I'm going to pull those. I'm going to go into each of those rows and grab the date, the cases, and the type. In other words, I'm going and saying, okay, I want the date, which is on the first one, the first column. Then I want the cases, which is the last column. And then I want the type. I don't really need the type, though, but I just wanted to show that you could string them all together so that, just make it look cool. Sorry. Hopefully that's okay. But anyway, that's really what I'm doing here. And everything here that I create is being saved into SwedenDat. Now you'll notice that, for instance, this piece over here, names, I wanted to change the headers of my columns so that they make a little bit more sense. I have multiple data sets that I'm going to be creating here, and I don't want multiple data sets to have the same headers because I might just confuse myself here. And so I don't want to have like just country, but I want to have, for instance, I want to have I want Sweden, or I don't want to just, for Sweden's dat here, I don't want just date, but I want Sweden date, or I want Sweden cases, so that I'm able to see that this is actually data that comes from Sweden. It's more editing in the code, but it helps you, it's more readable later on. So I'm going to run this thing here. And then I have this thing here called ggplot, and this comes from the library that we loaded earlier, which is called tidyplot, or tidyverse. That's why we load tidyverse, because tidyverse contains ggplot. Now when I run ggplot, boom, everything comes up, and I see this crazy graph. So you can see what happens is this is April, July, and October. This data is accurate as of, I think, a couple of days ago, within this week, maybe last Sunday. And so these are the cases you have here, the cases of the confirmed cases of coronavirus in Sweden. You can see that, for instance, in mid to late March, the cases began to escalate, and then they went kind of crazy between April, May, and June. In July, and then late June, it hit a high spot, and then July it began to calm down. You'll see that most countries have the same kind of form here. But what this really represents, though, in terms of, never mind the actual results of the coronavirus yet, though, what this graph represents is looking at many, many, many lines or rows of information here visually. And that is really the essence of data analytics, to take data in and look at things visually. So now we have this visual look of Sweden. I want to do the next thing I wanted to look at France at the same time here. So France, I've taken seemingly exactly the same code that we saw with Sweden, and I have changed the country now to France. Provence is equal to 0, or is nothing here. Type is still confirmed. The only thing I've really changed is where I saw Sweden before, I've now put France. And I've made a new data set here. You'll see that up here, for instance, in my data, under my global variables, I have Sweden data. In fact, you can click on this, I believe, and then you can see this is your data from Sweden. You see Sweden dat? That's my Sweden data. I'm going to do the same thing, but I want to do not Sweden, I want to do France. And the nice thing about this is that if you look at your headers, you'll see that Sweden date and Sweden cases are now my header names, which makes it easier for me to kind of, to recognize at a glance what my data is. Otherwise, at 3 in the morning when you're working on this, everything looks the same. So I'm going to go ahead and run my France dat, and I'll plot that too. We'll look at the plot, then I'll go back and show you the data in a second here. So this is the data from France. You can see that I've created my global variables just above this plot here. I've created a France dat here, which is 243 observations. And again, you can see that in April, March, going up to April, there was like an escalation of cases here. And then in the middle of April, there was a high point where we had over 20,000 cases. I think that's probably almost 30,000 cases, confirmed cases of coronavirus. Now, you can see now that these are just spikes here, okay? Now, we can't explain why that spike is there. We can infer things, but as a responsible data scientist, you need to go back and look at the data for what happened between March, late March, and June to make that spike escalate so quickly like that. What happened? It could be a glitch, but I don't think so. I think that maybe what it was in this case was that people didn't realize how contagious this thing was, or they didn't take it seriously. And I'm thinking, I'm just putting this out here, but I'm thinking that people didn't realize that this was a pandemic on the horizon, and so therefore it was just this thing that was popping up. Then once people began to realize that, maybe medicine kicked in, maybe more messages came out to the public saying you have to wear a mask, wash your hands, social distancing. Then people began to realize, and then the cases kind of went down. Now we can see that after July in France here, this could potentially indicate a second wave. I'm going to go back and move my picture again. I have to. I keep getting in the way of my own work. Why is that? It's just crazy. Anyway, so we have that, and so you can see that we might be looking at a second wave in France. And actually, if you look at the news and you read about the numbers of cases that they actually are seeing, that people have relaxed their hand washing and mask wearing and distancing because they thought that perhaps everything was under control. They probably thought in the middle of to late June, as I see in this graph here, they probably thought, well, things seem to be under control. I'm going to the pool now. I'm going to take all my friends with me, and we're going to sit around and have some fun in the sun, forgetting about the social distancing and masking. And so that's probably people letting their guard down. But I don't know that, and so I have to, in order to actually make that assessment, I can think that, but in order to actually make that assessment, I have to go and find out, how do I explain that data? I can't just say, oh, it's people being stupid. I can't say that. I have to actually say that, I have to do the research and find out. This is just a blip on my screen that says that there's something there. It's just like if you're looking at a radar screen, you see a blip on your screen and you have no idea whether that's an airplane or a UFO or Superman or what. You have no idea. It's something on your screen. You have to go to the charts and find out what could it be out there that's making that blip on your screen. Next, let's look at the US data here, which is also here. I'm just running all this stuff here. You can, I think you can see the code here. You can see that we have some pretty bad numbers here. It seems like in April to June, I think that people were still hyped up about flattening the curve, and then maybe people let their guard down, and then in July, things began to skyrocket, and then it seems that maybe in mid-July to August, we were at our peak, and now it seems to be coming down, thankfully. Let's look at Italy here. Italy had a really bad crisis in the beginning, and you can see that in April, they had a really bad crisis. I mean, you can see that they were one of the first countries to be hit so hard as they were, and they had to go through many, many deep ethical processes here to decide how they were going to manage this health crisis in their country. And we read about the news about how they had people in hospitals. They had more people than they had the resources to handle. And so some people were essentially just left in the hallway. And so that's just terrible. That's just terrible. But it looks like in July, things began to calm down. They had very close to zero cases. I think that maybe people began to relax their precautions, and now things are going to go up again. And so you can see that there's a certain type of a trend here. And this could be what they call the second wave. But you'd have to find out more to actually determine whether that's true. The next country I chose was Canada. In your code from last time, I put a little piece in there saying, please check out, run your own country and have a look. Excuse me. This is in Canada. And you can see that Canada, around April to June, had a really bad time too. It seems like all countries had a really bad time. But then things began to kind of taper off in July, and it began to taper off again in, I would say, August, and now things are kind of on the rise again toward the end of the year here. So I think we as a species, if we want to get rid of this virus here, we have to never release or relinquish our precautions here, and always go after this, keeping ourselves clean, keeping our hands clean, and wearing masks. Otherwise, if we don't do that, then this spike that we see appearing at the end of October is going to look like the spike that we saw in the middle of June. It's just going to keep going, which is why we can never let our guard down, and we can never turn our backs on our viral enemy here. I know that sounds like a some kind of speech here, but it's true. If we want to get over this thing, we can't turn our backs. Now, the next thing I wanted to show you in this code, and I'm not trying to scare anybody here. This is not what I'm designing this to do. But I want you, though, this is a PD course here, but I want you, though, to now be able to find data for articles that you see online and run code like this to actually determine, is this article that I'm reading true? I mean, are these results actually inflated? Is that really what the data says? Question everything. So now this next piece of code is for us to kind of question or we can look to see, we can compare countries here. This is where this piece of code that we're using down here, this is where we use the library called Plotly, which is, where was that? It's top here someplace. There we are. Plotly. Plotly is a magical plotting library. I mean, it's it allows you to have interaction with your plots, which I think is really nice. So we'll try and use more Plotly in our class. Otherwise, you'll notice that these other plots that we've been looking at, while they're visually appealing, you can't actually interact with these things, and so you really have to kind of, if you're looking to see if you're looking at the Y value here, or the Canada cumulative confirmed cases, you have to rely on these lines here to see what those numbers are. But with Plotly, we can actually see those numbers specifically by running our mouse over these things, and so we do have mouse over. Now, before we can actually use Plotly, the code is a little bit awkward looking here. We have to create what they call traces. In other words, you're making levels of data because you're going to be superimposing all this data into one canvas. That's what they call them. That's where we're working here. We work on a canvas. Your plot is actually a piece of art, if you will, on a canvas. And so trace 0, trace 1, 2, 3, and 4 are different colors of paint, which are all pasted onto this canvas. And the paint actually correlates to each of the plots that we've been looking at so far. So I'm going to say that trace 0 represents my Sweden DAT. And I have to say, in Sweden DAT, what column am I looking at here? And so that's what this $ here says. It says, what column am I actually looking at? Oops. The column that I'm actually looking at here is Sweden cases. In fact, I can go back to my data set here, Sweden DAT, and click on this, and you'll see this is Sweden DAT. I want to look at just this middle column here of cases, where you can see that the numbers are right there. So that's what my data is going to be. The other piece of data that I'm looking at is the date. So my x-axis, typically in any plot here, tends to be a chronological order as things go through. Your y-axis is going to be the number of cases here. So that's what this is all about here. So I'm really creating my y-axis points here. These are all the y-axis points, but they just call them your traces. I think you can use any other word you like. These are just variables. But I usually use trace because that's a convention that the Plotly papers themselves like to use whenever they're showing demos of using the same thing. So that's my Ys: Sweden, France, US, Italy, Canada. And then I have to establish my x-axis here. So I've chosen one of these traces here, and I'm saying the x is an array, which is from 1 to the length of my first trace. Now, I will say this. You may notice that in your global variables, Canada DAT, France DAT, Italy DAT, Sweden DAT, US DAT, they are all 243 observations. That's the nature of the data. The data has to, that's how many days the curator of this data decided that this data would extend. That's how deep it is, 243 days. That's from March. And so they are all the same length here. And so I just chose one of these things here because they are all 243. But I need some value of x on my x-axis here to keep track of where each point is going to be placed. That's why I just chose the first one here. But I could have used, like, for instance, 2 or 3 or 4. It wouldn't have made any difference. So I have that data. Let me just go ahead and run this before I actually forget. Otherwise, I'm not going to run it. As you run this, you shouldn't have any trouble. Now, the next thing here is I have my data. Now, with Plotly, you have to tell Plotly, you have to create I guess it's kind of what they call a data frame, where it's a parcel of data that Plotly is going to be using now to paint the canvas with the different graphics here. And so we have to make this data frame command here. And you'll find that many plotting functions in R, you have to make data frames, and that's just saying reserve this memory in the computer, pour in all the data that we're working with here, and when you're going to be plotting this thing here, when you plot when you make some plot, go back to this memory structure and pull the data out. And that's what this is all about. So I'm making a data frame here. I'll run that. And the next thing is actually very, very cool, because this is the actual code that actually paints the canvas with our different plots. So what we're doing now is, you'll see this first piece, Plotly. I have my data. My data is the data that I'm using. That's this data here. And I'm saying from my data, the x is just our x value here. We've already created our x. We could have used a more informative variable name, but I just use x, but it's up to you. Our y, for the first layer, or the first level, is trace 0. Trace 0, as you remember, correlates to Sweden data. Okay? So in this over here, I'm saying that y, for my first level, or my first layer, I guess I should say, is going to be the Sweden data. And so I need to give it a name. And so that's saying that this level is called Sweden. It's what kind of plot am I making here? I'm making a scatter plot. And I want points here. Yes, sir, Alex. You might need to. Okay, so there's an error. There's a question here that says that when we run this frame here, the number of rows is different. You may need to go back and rerun all the code all over again. What I recommend is just hit Control A, and Control A here, and run everything. And then you may have to fish out that same file again, because you'll remember at the top here you're going to lose this. This over here is going to say dump everything. But I think that might mean that there's some code that didn't get run. And so if I have that, and I have that problem fairly often too, what I do is I just hit Control A, and then I just hit the run button here, and then it dumps all my variables and then runs all the code all over again. If you still have some trouble, let me know, and we can come together and work that out. But that might help. Did it help? Then I'm going to run this. Okay, I'll just run all this stuff here. So then I'm going to run this. Then I have my data here. Then I run this over here, and then I've actually created now my canvas in memory. But to actually show the plot here, I just have to call that plot, which I call P, or plot. You can call it whatever you want. In fact, if you have a series of different plots here, you can call it like P1, P2, or you can have a more informative type of variable. It's entirely up to you. And then if I hit run again for P, you'll see that I have this. It takes some time here. I wonder whether I can hit zoom. If I hit zoom, can you see this? So there's this button you can click just above where the plots are. You can click on zoom, and maybe you can't see this. In fact, you can't really see this. That doesn't really help. So I'll try and open this up a bit here. My machine actually isn't very fast when I'm running zoom and I'm running all this other stuff at the same time. It tends to slow down. But this is actually the cool piece about Plotly here, and that is, in fact, I can maybe make this a bit bigger. Can I make this bigger? Sometimes it doesn't want me to make it bigger. There we go. But the thing about Plotly, though, that I really, really like, I've just lost it. Come on, give me my stuff back. Where's my stuff? Okay. If you hit the little house that's in the top here, I don't know if you can see this. The little house resets your axes, and so if you lose your data, if it's drifted off the screen, click on the little house and it takes you home. Now, one thing you can do here is you can click on, for instance, I can let's say I just want to look at a specific country here. I can actually double click on something. I can double click on US, and US is the data that's going to be in green, and so I can move my mouse around and I can see these points actually showing up. Hopefully your code works in the same way. Does it work for you? It works. Okay, so I think that the problem that we had here, that many of you may have also if it isn't working. Just go back to your code, select everything by hitting Control A, and running everything all over again. That is why I have at the top of my code, I have this piece of code here, which dumps all the variables which might be interfering. And then, for better or for worse, they're gone. And then your code should be able to run. But again, you'll have to find the file again, which is this piece of information right down here, where you have to find your data. But getting back to here, so I can now compare Italy, or I can US, France, and Italy if I want, and see how the cases are. Or I can remove US, and you'll see that as I move in bigger and bigger data sets here, the scale of the data is automatically changed. So here I'm looking at France and Italy here, but if I click on US, I'm clicking on this in the legend. You'll see that the US is such a huge piece of data now compared to these other ones, that the other ones like France and Italy are pushed down to the bottom. And it looks like that data is relatively minor compared to the US data. No data about the coronavirus fatalities is minor data, I can tell you that. But it appears that way though. And so what I'm saying is that when you're actually going through your data, it's important to actually look at the numerical values, as I'm doing right here. In fact, if I click on this equal sign up here, next to the little plot here, I can click on this compare button, this two equals bars, and I can run my data through this. I can actually see the numbers of each country here, and so I can actually compare numbers country by country, because the visuals might be misleading. Here we are saying that, or we see that the US data is towering over Italy. Let's get rid of the France data here. I'm just clicking on France and that's gone. So now I'm looking at just France and Italy here, and it looks like the US data is just towering over Italy. But the thing is though that the Italian data was actually quite significant too. 7,000 fatalities, almost 7,000 fatalities at its worst. Now the US has 80,000 at its worst right here, and so that's pretty awful, but it dwarfs the Italian data. And so I don't want you to think that if you look at this data that I can somehow discredit Italy here, because it doesn't seem like they had it bad at all, but actually they did. And so that's why you want to go through and this is where the responsibility comes from, and actually look at the numbers and see what the numbers themselves say. You have a visual here, but because US and Italy are really on different scales, it's hard to really appreciate the full magnitude of the Italian pandemic response. I'm going to move Italy here. Let's compare Italy with Canada. You can see that Canada, in fact, if I just look at Canada by itself, I can double click on Canada. Then I can just see what the Canadian data looks like. It seems like it's kind of a mess all over the place here, but that's just by nature of the data. I can bring Italy back, and I can compare Italy. It's funny how some countries have these, what I call these skewed markings here. So for instance, here we have peaks. This is skewed to the right, but we have a peak here where, you can see a peak here and a peak here. Some countries have peaks, like decided peaks, and other countries like Canada have sort of decided peaks, but they have many other pieces of data down here. Now, I would explain that, and I haven't actually gone through the data here, but I would explain that by saying that perhaps the Canadian data is a mixture of many different territories. It's not just Canada, but it's like other countries mixed in at the same time. You may have Nova Scotia, Newfoundland, and some other countries all mixed together there, and so perhaps each country has its own, I would say, its plot signature, which is a technical term for what the plot would look like, but its own signature for the pandemic, and they're all mixed together in the Canada data. And so if you're working on Canadian data, you may have to go back and further refine the data just to get mainland or data from just the provinces. So that's what they call wrangling, where you actually have to go through and find the data and actually bring in the data that you're actually looking at. Now you can compare. One thing I'm actually interested in was Sweden. Sweden was trying to do what's called herd immunity from the very beginning, where they thought those people who are going to get sick will get sick, and then once they get sick, they will recover, and then we'll get people naturally becoming immune to the coronavirus. That typically works for the flu, mild cases of flu, but the coronavirus is really not a flu. It's much more dangerous. Typically with the flu, though, you'll have a virus that comes through, a number of people get it, and then enough people have it so that that it doesn't, it's unable to spread. The virus is unable to spread in a particular population because it just doesn't find fertile ground. And so that's what they mean by this herd immunity, where enough people have got it so it just can't spread anymore. It can still spread to the single person here and there, but from that person that person would be presumably surrounded by so many other people who have immunity that they're not going to pass the virus on. The virus is not going to be, it's not going to make anyone else sick. So Sweden tried that strategy, and you can see that after about 150 days, 155 days, they had about maybe 1,200 some cases. And it seems to be dipping down here. And so you might make an argument that herd immunity does eventually work, but there are certainly some very rough patches that you have to go through first in order to get that herd immunity. In other words, you have to make sure that the elderly people and the young people and the people who have compromised immune systems are able to survive that herd immunity here. And so that was perhaps a controversial, I mean, this is what I say, but it was perhaps a controversial way of handling the pandemic. Anyway, I invite you, though, all of you, to go back to your code here and to just look at different countries and become familiar with what this data is saying, but also update this data. Like every time you run this thing, go back to these notes up here, go to the data reference here, right there, and download the very latest coronavirus. I mean, download it as a binary file using the download button. So that you have the most recent information, and then run it through your plots here. And then you can go back and you can try different countries. If I look at this line here, unique coronavirus country here, these are the different countries that I can look at, and then I can put them into my. I could use this same plot down here, or I could create a brand new plot where I'm looking at maybe countries in the southern hemisphere. I mean, maybe I'm looking at European countries. I want to compare countries in the southern hemisphere, whatever it may be. But you might actually go back to your code down here, and actually create a brand new plot. So what I would say is that hold on to this code though, and use this as reference so that when you're working on data that's either this data or similar data, now you have the ability to write some very sophisticated plots and to you can repurpose this code for other data sets. Anyway, take this data give this data some respect, though. I mean, it's reporting. It's a metric of suffering, which is actually very sad. Okay, so if there's no questions, I'm going to move on now from this data set. I think that we have about 15 minutes, it seems, or a little bit over, about 20 minutes, I guess, of class. So I'm going to go and I'll start the new slides here, but this is going to be kind of setting the pace. I'm hoping that when we are working with data, the first thing you want to do, your first impulse should be to make a plot of that data. I mean, to plot it, do some kind of plotting here to see what's in that data, to see what you can do with it to make it to understand it better. So now I'm going to go back to my slides here for today. I feel kind of ridiculous here starting. It's 12:07 on September 22nd here, but it's 12:07, and we're just starting the slides that I had anticipated. But these are actually some very important slides here, which really kind of go through the exact steps that we've gone through so far with this piece of code that I've just shown you. So our data set now is going to change. We're going to be talking about data that concerns cars and trucks and different kinds of vehicles. In fact, anyone here who's bought a car, I'm fairly sure that if you bought a car, you've probably spent at least a day thinking about, the mileage or different kinds of cars or making a comparison. Or in fact, if you've bought anything, I would say, if you've bought anything that's like a significant buy, that's something expensive, chances are you've probably spent a good amount of time going through you've been analyzing the pros and cons of these things. Even if you're like buying a computer or buying something else, you might spend a whole bunch of time going through the different specs and comparing specs between different products. And so that's really what we're doing here today. We're looking at the mileage between different kinds of cars here. In specific, we're looking at SUVs, trucks, and like I guess heavy cars and lighter cars. But the questions that we're asking though is, what classes of cars get the best highway mileage? And we may ask this question before we actually go out and start looking for a car. So before we can actually answer that question here, it would be very helpful if we could get some data and start just looking at some plots. And so I'm going to be looking at this data. I'm going to use this data here, and I'll show you this code first, and then I'll spend some time towards the end of these slides actually discussing what this code is doing, so that it helps you to understand the code. But for now, though, we're just going to use this code and use it as and discuss the analysis part. So I'm going to go back now to my RStudio, which we love so dearly. Don't forget, at the top of this line here, you have this code right here. I'm going to run this here. This rm list is equal to ls open and close parentheses, because I want to get rid of all my environmental variables, because it's a new project now. You always want to do that so that nothing interferes. You probably can't see what I'm clicking on now, but I'm going to click on the broom where the plots are. There's a little broom icon that I see in the viewer on the right-hand side. And when I click on that, it says, are you sure that you want to remove all items in the history? And I say, yes, do it. That means now my plots are gone. So I'm kind of starting out with a brand new, squeaky clean R environment. I guess you wouldn't call it squeaky clean, but still. So the code that I've just taken out of my slides, I'm going to paste in here. In fact, what I could do, maybe I should be more diligent here. I'm going to go and I'm going to open up a new file. I'm going to open up a new R script. And this is kind of what I'm talking about here. So now I've opened up an R script up here. I'm going to paste in my code that I have for my slides, which is this. And of course, it looks messy because check the data. So now I have to make sure that this is my comments actually get in the way here. When I paste these things in, you'll notice that everything kind of shows up on one line. But I'm going to do this way just in case anything happens. If the code works, I want to be able to hold on to it, but if it doesn't work, then I want to get rid of it. But I'm going to save this, just give it a file name, save it someplace. I'll just call this test. Oh, actually, I'll call it today's. I'm saving, but you can't see this, but I'm saving this right now. I'll call this 22 September code. And so now I have this, I've just made a file name. Now, notice that this is already beginning to it's already noticing some problems here in my code. There's that little red ball with the X. It says, what are you doing here? This doesn't seem to make any sense. In fact, if you go back to the slides, you'll see how the code should look. If you go back to the slides, you'll see how the code should look, and that should help guide you. But in this case here, just using RStudio, I'm going to load my tidyverse library, which I need. And tidyverse actually, and in fact many different packages in R, come with their own. They come with their own version, their own pieces of data, which is actually really nice, because when you're working with data, or when you're working with some new library, it's really nice to have some data set that you can use to practice on this data set. And so in tidyverse, we have car data sets. And so let's spend a moment here just to look at this car data set. I can see that there's a manufacturer header. I see that there's a model. There's displacement here. Displacement is it's a measurement of how much fuel I think it takes to accelerate the car. So heavier cars have larger displacement values than lighter cars. We'll talk about that in a minute here when you see the data. Then we have the year. We have the CYL, which is the number of cylinders in the car. And so you're going to see that heavier cars will have more cylinders, and more cylinders. I'm looking at this line right here for the Audi A4. The more cylinders, the more energy it takes to get that car moving, so therefore the higher the displacement value is going to be. And so displacement in cylinders is very correlated in this data. Then we have trans, which is the transmission. This is an automatic. We have the drive, the DRV, that stands for like the drive, like whether the drive, if it's rear wheel drive or front wheel drive. And so for this particular car here, it's front wheel drive. Then we have the city data, and city is the miles per gallon that you get when you're driving in the city. And how do I move over here so I can see more? Here we go. And then we have highway data. So that means how many miles per gallon do I get when I'm on the highway. And then we have this FL. I'm not exactly sure what that is. I think that's an internal, or that's some kind of classification here. I should check it and see what that is. I've never actually used it. But then I have class, which is, these are all what they call compact cars. And if I move down, for instance, I can see that I have mid-sized cars, I have SUVs, I have a two-seater, minivans, nice. I say minivans because when I was little, my parents, my father, had this devotion to our minivan, and it's like he would just not get rid of this car. And it was so embarrassing to have to be dropped off in school in a minivan because it was just too much car. It was just this enormous car, and it was just me going to school and me being dropped off by one of my parents. And this giant truck basically was showing up in the school parking way here, and then I would just jump out. It was just the biggest car ever, and I thought it was just too big of a car for little old me. Anyway, but still, I'm going to run this data here. So I have this. I'm going to load my library. I'm going to see or check out the data. In fact, if I type in view here with a capital V, that actually shows you the data. So you want to be able to use view every time you load a new data set here, so you can get an idea about what you're looking at. And then I have this other plot here. Oops, I keep running that, don't I? And then I have this other line down here called ggplot. And ggplot, if I run this, I just put my cursor on this thing here. Why is this not working here? Something. Could not find the ggplot. It's because it's not ggplot, it's ggplot. Sorry. ggplot. And then when I type in ggplot, and in ggplot, it's a function here where I have to say what the data is. Data is equal to MPG. MPG, miles per gallon. This data is built into the library tidyverse, and so we don't need to be any more. We don't have to. There's no files to load. Then over here we have this piece of the code here which just says I'm going to be writing. This is my canvas here, and on my canvas I'm going to be writing points. And so basically create a canvas on which I'm going to be mapping, or I'm going to be placing points. And so these are my points that I'm going to be using here, and they're all inside this what's called the aesthetic function here. And so the aesthetic function figures out the geometry of where the points are supposed to go. So I have an X point and a Y. It's a Cartesian product for each of these things here. And remember though that this dollar sign between the two different things here, this first word here, MPG, that's my data set, and this other one over here is the displacement. Don't forget what that means. Displacement is this column in the middle here. You can see right. I wish you could see this more clearly, but it's not meant to be. But you have this displacement. So I'm looking at, for the X value, I'm looking at the displacement, and for the Y value, I'm looking at the highway. And so that's kind of notation for how you do this. Data set. What about the data set? Inside the data set, find this column called highway. So we're looking at the displacement and highway. And so this is what this data is that I'm looking at now. This is saying, for instance, that as the cars become heavier, they have a smaller and smaller miles per gallon factor. So you see on the Y value here, the Y-axis, miles per gallon on the highway, and you see on the X, you have the displacement. And so as you get more and more displacement, in other words, as the cost of moving the car increases, you have lesser and less and less miles per gallon. You put more miles per gallon, more gallons per mile, or whatever it is. But you have less miles per gallon as the cars get bigger. Hopefully you can see that. And I know I'm kind of stuttering and making a mess of my words here, but as the displacement goes up, the number of miles that I can get for my gallon decreases. And you can see that from this graph here. And so this is something you'd use when you're working with your analysis of these cars. Now let's go back to our slides and see what else we can do with this stuff here. There's a bunch of other things I can show you. Oh, in fact, here we are. This is maybe a cheat sheet that you can use if you'd like on how to use the ggplot. I have it color-coded. So you can see that, for instance, the ggplot that we've used so far, we had to say what the data was, which is this chunk of information in the middle. And then we have over here this purple piece. That is our canvas. And the canvas is saying that this is where we're going to be putting our plots. And so we need to figure out what points are going to go into that canvas. And so you have this thing here called mapping. Mapping is saying, these are the points that I'm going to be putting into my canvas, which are right here. And mapping is actually asking another function called AES, or the aesthetic function, to determine how these points are supposed to go. So let's see this. Let's see this thing through here. So we have the ggplot here, which is saying, I'm going to create the canvas, and I'm going to ask mapping to tell me where the points are supposed to go for me to draw. And then mapping says, sure, I'll give you those points. Let me just call my dear friend AES function, and that function will tell me where the points are supposed to go. I will arrange them and then give you the blueprint so that you can put them on the screen. That's really what this is. And so hopefully this information here is useful. You can have an idea about it. It will help you to create your own functions here. But every time you use ggplot, though, the code is going to be the same. That's one thing that's nice about R, and that is that while the code first looks like just line noise when you first see it, it does actually, it's very consistent. It's like this is the code you'd use for ggplot. So anyway, getting back to where we were, this is the plot that we just saw, and so this is suggesting that as the displacement becomes, as the cars get more or heavier and heavier, and they cost more and more energy to move, then the miles per gallon is going to be decreasing. And that makes sense because heavier cars have fewer miles per gallon. Ask anybody who drives a tank to work every day that it costs them probably like gallons per mile rather than miles per gallon. Smaller cars tend to do better in terms of in terms of mileage. So, but that isn't very helpful to us though, because there's something wrong with this plot though. Can we learn more from this data? We have a Cartesian product here, but we ask ourselves, is there any way that we can learn more from this plot? We can. Who has? So actually, let me just ask you then. Let me ask you, what would you? Anyone who has an idea here, just say it. What would you introduce to this plot that would give you some more information about perhaps these pieces of information, these points that we're looking at? Wes, what do you think?
Some way to differentiate between the points, because it may be between weight and mileage, but of course who made them, how they made it.
Yes, that's right. So there's metadata that we can go through. Anyone online? Do you have any ideas on how we can get more information out of this?
Well, maybe we could have like a line of best fit.
Yes.
That describes a trend.
That's exactly right. Yes. So, and anyone else? Can anyone else think of anything else that we might use? Did someone say color? Yes. That person, you are, sorry?
There's maybe like some data labels to help read the most important data points.
Absolutely. These are all pieces of information that we can incorporate into our plot here. So what I wanted to stress here that is that just because you end up on a plot that looks like this, that's not the end of the story here. You can still get more information out of these things here. So you can always find more information here. And so today's slides are really about kind of exploring this. So supposing I did this, the next plot, I created the whole thing in blue. It was black and now it's blue. Have I actually added any more meaning into this plot? I'm seeing some heads no. No, we haven't. It's all the same color all over again, whether it's blue or red or pink. It doesn't matter. In fact, I actually added this here because now you have it in you. You have it in your code here to add blue coloring if you wanted to. So I'm going to copy this and I'll just show you how that looks. While that is cool, I want to show you. Put that there. While this is all really cool to do, I want to show you though that just because you create a blue plot. Oops, sorry, you can't see that. There we go. Right here, just because you've created a blue plot, it doesn't mean that you have actually made any more sense of the data. Always be on your lookout here for cool-looking plots which actually give you nothing. This gives you nothing. In fact, we have the same data from when it was in black and white. Now we have it in blue and white, and so it means nothing. And so you have to be on your lookout for these kinds of plots here. It doesn't actually contribute anything to your overall understanding of this. And I know that when you're looking at, when I see articles, I'll see some kind of plot that the article is put together, and I think, wow, that looks really exciting. But that's all it is. It's a design for a t-shirt. It's not actually more information. This is more information. Now what I'm doing here is I'm going to add some information about, I'm going to maybe help to classify one point from the next. We'll get back to more color in a second here, but when you look at the plot like this, for instance, it's just a bunch of points. But I want to know about, for instance, are my classes of vehicle changing any as I move from as my displacement becomes heavier and heavier? And so now I have this code here where I can actually add, for instance, some sizing information. So my points actually become bigger according to the kind of car that they are. So you can see it in this in my legend. I have class information. I can see, for instance, the two-seaters, the compact, the midsize, the minivan, the pickup, subcompact, and the SUVs. And this helps me to kind of get a notion of, as my cars get heavier, in other words, as my cars become more like pickups, subcompacts, or SUVs, my displacement goes down. The cost of moving the car, my displacement goes up, but my miles per gallon on the highway go down. They're low. This is saying, for instance, my worst car, I'm looking at this dot at the very, very bottom here, just before the 5 point, basically just above where I am right now. This point is an SUV. It must weigh a ton. It's not the most difficult car to get moving. It's not the highest displacement here, but it appears to have about 5 miles per gallon on the highway. Now, you're probably thinking, so what? That's no big deal. How funny is that? Well, imagine that there's a million cars driving on the driveway, or driving on the highway rather, of that caliber in our world. Imagine how much fuel is being expelled into the air to get these cars going. And so this is actually very insignificant data in terms of environmental issues here. And so you might decide, for instance, that that car is just too low. In fact, you might find that most of these SUV cars just have too much, or they use up too much energy to move, and there are just too many cars on the road that are like this. I mean, that's something. But let's just go ahead and look at that code in action here, just so you know that it can be run. I'm going to go back to my RStudio. I'm going to notice I'm dumping all this code into my editor space here so that I can actually work with it. And when I do this, if I run this, I now have this information here. I think that's class. I think that I got kind of carried away here, and so I'm sorry for keeping you guys an extra minute. I'm going to stop here. When we come back on Thursday, we'll finish up these slides, I hope, and then we'll move into some other fun stuff. I didn't mean to spend so much time on the coronavirus, but I do think that's an interesting piece of code, though, because now you can use that same code for more coronavirus exploration, or if you have other data that looks like coronavirus data, you can apply that same code to that or modify it in some way to make it work. Anyway, I will see you on Thursday. Everybody, stay well. I will see you soon. And thank you for being here.